You're most welcome, dear viewers. This is Tr Isaac. I'm yet again back here for science. And in this episode, we want to look at work and mechanical advantage. We shall need to first of all find out what mechanical advantage is. Mechanical advantage is the load, the ratio of the load to the effort. The ratio of the load to the effort. All right. Let's look at MA. This one simply means mechanical advantage. It is a short form of writing mechanical advantage. That is MA is equal to the load over the effort. So you look at the load you're trying to carry and also look at the effort you're supposed to use to move that load through a certain distance. Now, one of the advantages of mechanical advantage, it helps to simplify work. It simplifies work. Here we shall look at the number of times it simplifies work. So it is another way of defining mechanical advantage, the number of times a machine can simplify work. Okay? So let's have an example. Let's look at this first example. A man uses effort of 50 newtons to raise a load of 100 newtons, as shown below. Okay? Calculate the mechanical advantage of the machine. In this case, you all remember very well we looked at an inclined plane. This is an example of an inclined plane. It has a slanting surface and it is raising an object through a certain distance, that is the height. At this side here, 6 meters is the height, and it is the distance through which the load will be moved. So sometimes you may be asked to use distances, okay? Load distance over effort distance. That doesn't change so much. So in this case, a man is trying to raise this load, which is of 100 newtons, through this distance to this height. The height is 6 meters. This is the foot, and this is the point where the load has to reach. So we want to see how is work simplified here using mechanical advantage. Okay? So you first of all state your formula that mechanical advantage, I told you MA simply means mechanical advantage. MA is equal to load over the effort. Now when we go back to our question, we've been given our load is here, 100 newtons. The load of 100 newtons. Alright? That will be our load. Then the effort is also given. It is here, 50 newtons. After identifying those two forces, you can come here and substitute. Substitute for the load, substitute for the effort. Therefore, we have our load as 100 newtons and our effort as 50 newtons. So this one, I'll cancel a 0 by 0, then by 5, 1, by 5 here, shall have a 2. So that's where the 2 comes from. Now you'll understand, you'll note that mechanical advantage does not have newtons. Why? Because we are dividing newtons out of newtons. Newtons by newtons. So those ones will cancel each other and we stay with 1. So Newton divided by Newton, it becomes 1. So that's why mechanical advantage does not have units. Okay? So we are noting that MA, or mechanical advantage, is the number of times a machine simplifies work. It tries to simplify work as many times as possible. Okay? So that is what we are noting down here. Then we are also saying that friction lowers mechanical advantage. When you have too much friction, the number of times that work you're trying to do is simplified will come down. And when you don't have friction, you have many times in which work is simplified. I've also told you a mechanical advantage has no units. Okay? And I've showed you the reason as to why we don't have units. We are dividing load, which is in newtons, and effort, which is in newtons. Therefore, we shall cancel the newtons with the newtons, and we shall stay with nothing totally. So that's why we have mechanical advantage as 2. We shall look at mechanical advantage more clearly when it comes to pulleys. We shall look at pulleys in our next episode, and we shall see how we use mechanical advantage even on pulleys. So we shall be finding out mechanical advantage of pulleys. All right, let's move to work. It is stated here that work is the product of force and distance moved. You look at the force applied and the distance through which you're moving that load, okay? When you multiply those two, you have got work. And you said that the units for work are joules. Those are the units. It's not like mechanical advantage which does not have units. Work has units and they are joules, okay? So you get the force multiplied by the distance. This word product, from your mathematics, you know very well that when they talk of a product, they mean you multiply. So a product is a result you get after multiplying. Okay? So multiply the force and the distance through which the load moves, and you get the work done or work. Okay? Let's look at precisely force, what force is. Because we have already talked of applying a force, What do we mean by applying a force? All right. Force is a pull or push on an object. Anything that can cause motion. Any force applied to any object and it causes motion will qualify to be a force. We have examples here. We have gravitational force. Gravitational force is that pull towards the center of the earth. Okay, that force which pulls towards the center of the earth, if I try to throw this chalk up, it has to come down. Okay, something is pushing it back. Why doesn't this chalk, if I throw it up, why doesn't it go further? It has to come back to my hands. Reason, there is that force which is pulling it down towards the center of the earth. But there is a certain point where you reach and you experience zero gravity. That is up in space. Where there is zero gravity, there is no force, so no movement. If you have been put in there, you just have to float. Okay? Yes, zero gravity is also some fun, but you can only experience it when you leave Earth and go up. So where there is zero gravity, you can put chalk in space and it stays there. If you want to drink water, you just pour water and you get the water in your mouth. So a drop of water can stay in one place like this, okay? Because it will have strong cohesion forces holding the molecules together. All right, let's look at friction, that which opposes motion of an object. If you are trying to move any object through a certain distance and it is trying to oppose, the force which is making it to oppose that motion is what we call friction force. That one was explained earlier on when we were beginning machines, okay? And you saw how friction is a nuisance force, how friction is a useful force, okay? Nuisance meaning it's when is it useless? When don't you require it, okay? Yes, you have to go back and revise on that, candidates. Now, we have weight. Weight is considered looking at also the acceleration due to gravity. Okay, it is acting on by acceleration due to gravity. It is different from mass. Weight is the heaviness or lightness of an object. And mass, remember, is the quantity of matter contained in an object. So, those molecules that form that matter, what quantity do they have? That is what mass is. It is totally different from weight, because when we are talking of mass, we don't look at gravitation force. Okay? Now, we have buoyancy. Buoyancy is that force which makes objects weigh less when put in water. they become buoyant. Okay? Remember I talk of buoyancy when it comes to a fish. What keeps it buoyant in water? That is the swim bladder. You go back and revise that. That is P61. Okay? So, if you put a piece of wood, try to push it in water, it will keep coming up. Not because it is less dense, but it's also that force acting upon it. Okay? Which is normally called upthrust. Upthrust. Alright. We also have magnetism. During your first term, you looked at magnetism, the force which enables a magnet to attract other magnetic substances. It is a force. Now, the unit for force is a Newton. Newton is derived from one scientist who was called Isaac Newton. So Isaac Newton did a lot of physics when it comes to force. So his name was used to refer to this unit of force. That's where it comes from. So it is from Isaac Newton that we got the Newton. Okay? Alright, let's look at how we get force. If at all you have been told to calculate force, can you be able to work out force? Let's go here. Force is given by mass times acceleration due to gravity. Force is equal to ma, in other words. What does ma mean? Where m is the mass of the object, then a stands for the acceleration due to gravity. I told you already, there's that force which acts on objects, pulling them towards the center of the earth. That is acceleration due to gravity. And in this case, it is a constant. It doesn't change. When you advance, you'll be talking of 9.81, but at your level P7, you take 10 newtons, okay? But when you advance, you see it changing to 9.81, but it still will be a constant. So, this is the force that we shall multiply by the mass to get the force required, okay? And that force is the acceleration due to gravity, which pulls objects towards the center of the earth. All right, let's look at an example. Calculate the force required. Calculate the force required to raise an object of 50 grams through a distance of 10 meters. Calculate the force required to raise an object of 50 grams through a distance of 10 meters. In other words, they are telling us 50 grams here. We need to find out what has been given. We have 50 grams there. We also have 10 meters here. So, what is given? We have mass. Mass given is equal to 50 grams. Okay? We also have the distance through which the object is moving. That is the distance. Distance in this case is equal to 10 meters. Okay? 10 meters. Now, let's go back to our formula and see whether we can substitute this in order to get the force required as the examiner is stating. All right. We shall move on to this side. We have force is equal to ma. That is what you have to first state when you're going to calculate for force. Let us know the formula you're going to use. It will help you to just substitute in and get the result. Okay. Force is equal to mass times acceleration due to gravity. Acceleration due to gravity is always 10. That one you don't have to look for it. It is a constant and it is always 10. Okay? Now, let's substitute for mass and substitute for acceleration. We have been given our mass. We have been given our mass here as 50 grams. We have been given a distance, but we don't need this distance at the moment. It will come in where we are going to calculate work done. So, 50 grams, we shall write it there, and also multiply it with the acceleration due to gravity. which is a constant, that is 10. Don't confuse that 10 with the 10 given here through a distance. This might confuse you. Sometimes if it is 9, you can't put 9 there, okay? So it is 10 now, but it is meters, it is not a force. That's why you are supposed to write whatever has been given in the question and see whether you can use any of them to substitute. Very good. So let's continue. We shall multiply our 50, which is in grams, times the 10 newtons. And 50 times 10 will give us 500 newtons. 500 newtons. So that is the force. Always remember to put the units. Don't forget the units, because if you don't put units, no one will mark that, because the examiner wants to know whether you're talking of goats, when you're talking of sheep, or whatever. Okay? So we shall do more examples on that, but let us concentrate now on work done. We shall come back and use this very example to find out the work done. Okay? All right. Work done. Work done is defined as the force multiplied by the distance. Force multiplied by the distance. Force multiplied by the distance. You get the force, multiply it with the distance through which an object is going to move. Okay? That is what we call work done. So we have an example here. Find the work done by a man pushing a wheelbarrow through a force, through a distance, using a force of 10 newtons through a distance of 5 meters. I'll repeat that. Find the work done by a man pushing a wheelbarrow using a force of 10 newtons through a distance of 5 meters. Okay? Now, this is what we call calculating work done. Work done is given by force multiplied by the distance moved through the load moves. Okay? Now, a man using a wheelbarrow uses a certain force, which is 10 newtons, it is given, and is pushing a wheelbarrow through a distance of 5 meters. Okay? So let's look at what has been given. We have been given the force as 10 newtons. We have also been given the distance as 5 meters. Let's go ahead and substitute in our formula. Okay? Work done is force times distance. Now, work done, we shall substitute our force. Given force is 10 newtons, we shall substitute 10 newtons. Then, through a distance of 5 meters, we shall substitute for 5. And therefore, when you multiply 5 times 10, you get 50. Now, the units for work done are joules. The units for work done are joules. That is our final answer. Let's look at another example. The previous example. The previous example where we were given mass and also given distance. This one is very important to note, okay? We shall look at this very question and calculate the work done here. What work is done in this question? Calculate the force required to raise an object of 5 grams through a distance of 10 meters. This is how the question will be. Calculate the work done. The work done to push an object of 50 grams, okay, through a distance You can have any other distance. A distance of 2 meters. Let's first of all find out what has been given. Given is mass, which is equal to 50 grams. Okay? Then given also is the distance. The distance is equal to 2 meters. Let's write our formula then. What is work done? WD simply stands for work done. What is work done? Work done is the force times the distance. Force times the distance. But when you look at our question, we don't have force. That means we need to first of all look for force. Let's go and look for this F here, the force. After getting the force, we shall be able to find out the work done. Okay? So, you will say, but force is equal to MA. You have to be smart. Force is equal to MA. And now, we have mass here. Acceleration due to gravity is a constant, that is 10. It is known. Alright? Where M is mass and A is acceleration due to gravity. Therefore, our force will equal to the mass, which is 50, times acceleration due to gravity, which is 10. Okay? Now, let's look at what we get. Force, therefore, will equal to 50 times 10. That gives us 500. And remember, the unit for force is newtons. But that's not the answer. They asked us to find out work done. Let's go ahead and find out work done. So after getting the force, we can substitute force. Substituting for force in WD is equal to force times the distance. Okay? We already have distance. We are now happy we have even the force. Okay? Alright. Work done is equal to, our force is 500 newtons. You can leave the units out. Times our distance. Distance is given as 2 meters. We shall come and substitute for distance as 2 meters. So work done in this case is equal to 500 times 2. You can do side work if you can't multiply this quickly, but the easiest way is 5 times 2. You get a 10 and you add those 2 zeros. So that is 1000. Okay? And this one is given in joules. Okay? Joules, you can also write it as J. It can be denoted as J, as simple as that. Alright, that is one of the ways you can calculate for work done of any given machine on Earth. Okay? Remember, the tips are find the force, find also the distance, because work done is a product of force and the distance. Don't confuse that with the force. Force is the product of mass times the acceleration due to gravity. Okay? We saw that earlier on. Now, remember one thing. I told you that friction opposes motion. If you have too much friction in doing work, you'll use a lot of effort. You apply a lot of effort to do a certain piece of work. What you have to do as a wise person is to try to reduce friction in any of those machines such that work can be easily done. If you are pushing a wheelbarrow, some wheelbarrows normally make noise, those noises. You can try to lubricate the wheelbarrow such that when you're pushing it, it's very easy for you to do work with it, okay, on any grounds, okay? Then remember, acceleration due to gravity is a constant. Acceleration due to gravity is a constant, it doesn't change, okay? Especially here on Earth, it doesn't change. I've told you only find zero gravity when you go up in space, where you will float in air. All right, with those few tips, I would like to stop here and wish you all the best in the future until we meet again in the next episode. I've been yours, Teacher Isaac. Try to subscribe to our YouTube channel in order to get all the videos that we keep uploading here. Thanks so much for watching and listening. See you next time. Bye.